This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable, source-backed California materials, so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A duct system can be neatly installed and still put the project in trouble if leakage testing is scheduled after the work is concealed. The central field decision is simple. I treat duct leakage readiness as a hold point, before drywall, not as paperwork to chase at the end. The leakage test measures air escaping from the duct system under a controlled test condition. For a general B contractor, the important skill is not designing the duct layout or calculating friction loss. The important skill is coordinating the installer, the certified rater, the drywall crew, and the correction window so the system can be tested and repaired while the joints are still reachable. A supply leak can send conditioned air into an attic, crawl space, or another unconditioned area instead of delivering it to the rooms. The exact indoor effect depends on the leak location and the surrounding system. For field supervision, the supported practical effect is enough. Leakage wastes delivered air, changes system performance, and becomes harder to correct once finishes cover the work. Imagine a contractor on a project that intends to use rough-in verification. The drywall crew is ready, the board is stocked, and the schedule is compressed. The duct installer says the joints are sealed, but the leakage verification has not happened. If the contractor releases drywall, a failed joint may disappear above a finished ceiling. The same correction that was accessible during rough framing may later require opening finished work just to reach it. That is why I use a pre-drywall hold point. Before interior finishing moves forward, I confirm the intended test path, confirm that the duct system is ready for that test condition, and confirm that the rater is actually scheduled. A promise that somebody will test it later is not the same as an inspection-ready plan. The source material uses the familiar term Home Energy Rating System Rater, and also notes the newer energy code, compliance rater terminology. The field lesson is the same either way. A certified third party performs the required verification, and the general B contractor coordinates access, readiness, corrections, and documentation. I put the rough-in pathway on screen because the order is worth remembering. When that pathway is chosen, the exposed duct system is installed and sealed first. Next, the contractor chooses whether the rough-in test will occur with the air handler installed or without it. Then the test happens before interior finish, accessible leaks are corrected, and only after that does concealment move forward. If the air handler is installed later, its supply and return plenum connections still need proper sealing and final visual verification. At the finish stage, the register boots must be sealed to the drywall. The sequence is not complicated, but the two test conditions create different numbers. That is where people commonly mix up the rule. For a new single-family dwelling, when the air handler is installed and connected, total duct leakage must not exceed 5% of the air handler airflow. That 5% limit applies to a completed new system and also to a rough-in test when the air handler is already part of the tested system. If the rough-in test happens before the air handler is installed, the duct system alone must not exceed 4% of the air handler airflow. That test does not yet include the later air handler and plenum connections. When the equipment is installed afterward, the final verification includes a visual check that those later connections are completely sealed. The comparison table separates the major limits. New single-family construction is 5% total leakage with the air handler installed. Rough-in without the air handler is 4% total leakage, followed by the required visual check of the later connections. Multifamily work uses a different path, with no more than 12% total leakage or no more than 6% leakage to the outside. Qualifying alterations to existing systems use 10% total leakage or 7% leakage to the outside. The percentage is tied to nominal air handler airflow, not to floor area, duct length, or register count. For a simple example, if a new system has 1,000 cubic feet per minute of nominal airflow, 5% is 50 cubic feet per minute. I use that example only to show what the percentage is measuring. The certified test and the approved compliance documents control the actual project result. A useful memory connection is this: new work is held to the tighter 5% limit. Existing system alterations have the more lenient 10% total leakage path. Rough-in without the air handler is the special 4% condition. Alteration rules start with a different question: how much new or replacement space conditioning duct is being added to the existing system? When the alteration adds more than 25 feet of duct, the altered system enters the diagnostic testing pathway described in the source material. For that altered system, the primary limits are 10% total leakage or 7% leakage to the outside. Those alteration limits apply to an existing system that may include concealed portions that were not built as a completely new, fully accessible installation. Do not confuse the 25-foot trigger with the separate 40-foot exemption. The first number looks at how much new or replacement duct is added. The second addresses an existing duct system that contains less than 40 linear feet. That small existing system is exempt from the alteration duct sealing requirement through visual inspection. There is also a limited path for an altered system that cannot meet the leakage targets because remaining leaks are inaccessible. This is not permission to stop after a weak sealing effort. All accessible leaks must be sealed. A certified rater then verifies the condition through visual inspection and a smoke test. The smoke test helps confirm that the remaining leakage comes from inaccessible, previously existing portions of the system. I want to keep the project management lesson clear. On an alteration, I identify the amount of added duct, the total extent and condition of the existing system, the applicable test pathway, and any supported exception before the crew starts closing work. I do not wait for the end of the job to discover that the wrong compliance path was assumed. The leakage number is only part of verification. The rater also checks whether the system is presented in its normal operating condition and whether the visible construction details match the compliance requirements. One common shortcut is temporarily taping off an outside air connection during the leakage test. That is not allowed. An outside air duct connected to the central forced air system must not be artificially sealed or taped off to improve the result. If the system has a motorized damper that normally closes when outside air is not required, the damper may be placed in its normal closed position. The distinction is normal operation versus a temporary test trick. The register boot detail is another trade coordination point. At the finish stage, each supply and return register boot must be sealed directly to the interior drywall. The metal boot and the gypsum opening belong to different scopes in many schedules, but the air boundary does not care which subcontractor created the gap. I make sure somebody owns the final seal before the rater arrives. Building cavities are another red flag. Stud bays, joist spaces, and platform cavities cannot be used in place of fabricated ducts as plenums or platform returns under the verification criteria in the source material. A framed cavity may look convenient, but convenience does not make it an approved duct. I put the visible checkpoints into one inspection table. Keep the outside air connection in the proper operating condition. Seal every supply and return boot to the drywall. Do not use building cavities as substitute ducts. If cloth-back tape appears, it must be covered with mastic and secured with drawbands. Use closure products that meet the applicable Underwriters Laboratories 181, 181A, 181B, or 723 requirement. When suspected asbestos is present, do not disturb the material merely to chase an energy test. That table is a practical site walk tool. It does not replace the approved plans, current compliance forms, product listings, or the authority having jurisdiction. It helps the general B contractor recognize whether the work is ready to be presented for verification. The word duct tape creates one of the most persistent material mistakes in this topic. Ordinary silver cloth-backed rubber adhesive tape is not automatically an acceptable standalone duct closure just because the trade name sounds right. The source-backed rule is specific. If cloth-backed tape is used on a joint, it must be covered with mastic and secured with mechanical drawbands. Mastic is the paste-like sealant applied over the joint to create the air seal. The drawband provides mechanical restraint at the connection. The complete closure method matters more than the familiar appearance of the tape. Other tapes, mastics, and aerosol sealants must meet the applicable listed standards. The California Mechanical Code references underwriters, laboratories 181, 181A, 181B, or 723, depending on the closure system. I do not approve a product by color, shine, or what the installer calls it. I look for the listing, the intended application, and the complete installation method. Suppose I walk a rough-in and see bare, cloth-backed tape wrapped around flex duct connections with no mastic coating and no drawbands. I do not need to wait for a rater to identify the defect. I can direct the heating, ventilation, and air conditioning contractor to correct the closure while the joints are still exposed. That is exactly the kind of defect recognition that belongs within General B field supervision. The same principle applies to boots and plenums. I look for a continuous sealed boundary, not a collection of materials that merely looks finished from the floor. A neat joint can still be incomplete if the required closure system is missing a component. Existing ductwork can introduce a more serious boundary. The Energy Code provides an exemption from duct sealing requirements for existing duct systems that are constructed, insulated, or sealed with asbestos. That exception must not be treated as a casual visual guess or as permission to handle the material. Old white or paper-like insulation can be a warning sign, but appearance alone does not confirm asbestos. If existing material is known or presumed to contain asbestos, I stop the ordinary sealing approach and coordinate the required hazardous material procedures. California safety rules govern disturbance, hazard communication, exposure control, and worker protection. The General B lesson is judgment. I do not scrape, cut, or coat suspect material, merely because the alteration would otherwise enter a leakage testing pathway. I identify the condition, preserve the work area, involve the properly qualified parties, and document the applicable Energy Code exemption and safety process. This is a useful example of two rule systems meeting at the same job. Energy compliance asks whether the altered ducts must be sealed and tested. Occupational safety asks whether the existing material can be disturbed and under what controls. The correct field decision respects both boundaries. An energy target does not erase a hazardous material obligation. Before drywall, I use a short supervision check. Is the duct system complete enough for the chosen test condition? Is the air handler included or not included? Is the correct 4% or 5% limit understood? Is the rater scheduled? Are the joints exposed so failures can be corrected? Before final verification, I check the later air handler and plenum connections, the register boots at the drywall, the outside air connection in its normal condition, the absence of cavity returns, and the listed closure methods. On alterations, I separate the more than 25-foot trigger from the less than 40-foot existing system exemption. I also confirm whether the asbestos exception or the inaccessible leak verification path actually applies. The memory line I use is simple. Test while the work is open. Seal the real air boundary. Never fake the normal test condition. Stop when suspect asbestos changes the job. Based on the published Contractor's State License Board study outline, this topic belongs within testable heating, ventilation, air conditioning, and energy efficiency material for the General B contractor. The value is not memorizing isolated percentages. The value is matching each percentage and exception to the right project condition, then sequencing the trades so the required proof can happen without destructive rework. I made an audio practice quiz specifically for this duct leakage testing and sealing material. The questions are read aloud and you answer by tapping, because I know you may be studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the limits, the test timing, the sealing materials, or the alteration exceptions. I read those questions and use them to make the lessons clearer. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want this material to feel practical every time you press play.